This is a review over the answers, the solutions for solving polynomial equations, the pre-assessment. So in this section we learned four different techniques. We solved using the zero property by factoring, creating two equations, something like that, using the zero property. We also could have had something like this. That's also the zero property. The next one was isolating, solving for x, technically x squared, where we would isolate the variable and then taking the square root of both sides. So when we had something like this, we would take the square root of both sides. And once you do that, the other one is completing the square. That was another technique, and that looks something like that, where we would complete the square, and we'd add 4 to both sides, which would create a binomial square, and then we would take the square root of both sides. And then the last one that we learned was the quadratic formula. And the quadratic formula tells you that the variable, whatever variable you have, x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And here's the thing about these. And in this assessment, we're going to use specifics. So I'm going to want you to use this technique for 4 problems. I'm going to want you to use that technique for a couple problems. I'm going to want you to use this specific technique and this specific technique. But we need to understand is that we can use the quadratic formula for every single type of problem, any type of problem that we have. So if we look at all of these problems, I guess you can't use it for this. We would have to simplify that first. But you could use it for all of these problems. You can use the quadratic formula, quadratic. So it doesn't matter which problem, you're going to be able to use the quadratic formula in every single problem. So that is something. Let's not clear a page. Clear the ink, please. We can be able to use that. Now, if we look at the zero property only works with A times C problems, problems that we can factor. So if we look at this problem, we know that we can do this because it tells us. But if we look at, let's look at this one. Factors of 28. Are there factors of 28 when subtracted equal negative 12? So we have to be aware of, sorry, I'm moving my computer so I can move that page a little bit better. So are there factors of 28 when subtracted equal 12? So 1 and 28, 2 and 14, 3 no, 4 and 7. Signs are different. Bigger is negative. So notice none of these equal the middle. Oh, yes it does, sorry, that one. So we could use A times C. We could have factored for this one, but I want you to complete the square. Here we go. Well, right, factors of negative 18. Well, I'm sure that some of these, because they're not irrational. The ones that end up being irrational are the ones that we can't use A times C. But we're not going to be able to take A times C for everything. We can't complete the square for number 15. You're not going to be able to complete the square, so you can't use that technique. So you can't use completing the square for number 15. You can use quadratic formula. You can I don't think you can factor. So the only one that you're going to use is quadratic formula for number 15. So it's kind of important to know why we're doing all these, why we're trying these 4 different techniques. And the reasoning being is some of them are going to be used better. Let's go back to here. Completing the square. Right? Our a is not 1. Do we really want to use the technique of completing the square for this? No. Quadratic formula would probably be better. If we divide everything by 6 here, you end up with an odd b. That would be 3. Do you want to complete the square with an odd b value? No, it's not the most efficient. So I would probably use the quadratic formula here again. Now, you should be comfortable with all these 4 techniques so you can do it no matter what, but just understand that you can use some of these in every single problem. So that being said, let's start with the solutions. So since we have 2 binomials, a binomial and a binomial multiplied equaling 0, we're going to set each one equal to 0 and solve for the variable. Divide by 2, p equals -7/2. Subtract 1, divide by 4, and we get p equals -1/4. So my solutions in numeric order are going to be -7/2, -1 1/4. Sorry. -7/2, -1 1/4. Good. All right. I don't have the answer key, so let's look here. Now, we are going to use a times c. A is 1, c is 25. Factors of 25. The signs are the same. When that sign is positive, we know that the signs are going to be the same, and then we look here and we know that they're both positive. That gives me 26, that gives me 10. This is equal to my middle value, so I'm going to use these 2 values for my b. I'm going to split my b into those 2 values. I got 5 and 5 from these 2 values. Plus 25 equals 0. And now I'm going to factor by grouping. I'm going to group the first 2. I see that there's a common factor of an a. I'm going to look at the second 2. I see there's a common factor of a 5. And we get a plus 5, a plus 5. And that ended up being a binomial square. So we could have done that. We set each one equal to 0. And subtract 5. Subtract 5. And my solution is -5. I don't list it twice. I'm listing the solution. There's only one solution in this problem. And knowing that, you know that parabola, if it only has one intercept, remember these represent the x-intercepts. So this parabola is going to touch the x-axis at -5. So that's why we're finding that out. This is a point, it's a location, it's a value, it's an important value. So we'll leave this just for understanding, but this is your answer. Let's look at number 3. So the first thing is there a common factor? I also have to make sure that it's set equal to 0. Is there a common factor amongst the 3? No. So I have to do a times c. This is going to be a big one. A, C, 420. Mr. Mac, what are you doing? 2, 210. 3 goes into it. I know 3 goes into it because 4 plus 2 plus 0 is 6. So now I use my handy dandy notebook, right? 420 divided by 3 gives me 140. 4, does 4 go into it? Yes, 4 goes into it because 4 goes into the last two digits, 20. So 420 divided by 4 gives you 105. 5 goes into it because it ends in 0. 420 divided by 5, 84. 6 goes into it because 3 and 2 go into it. So, and that's 70, because 6 times 7 is 42. 7, yeah, I would assume 7 goes into it, and 7 probably goes into it 60 times, yep. 8, does 8 go into it? 8, we're going to just have to use the old calculator. Nope, 8 does not. 9, 4 plus 2 is 6, no. 9 doesn't go into 6, so 10, yes, 10 and 42. And 11, let's see, 11, no. 12, yep, 12 goes into it. 420 divided by 12 is 35. Let's use this. 12 and 35, and we can stop at 12 and 35. We know that my signs are going to be the same, and they're both going to be negative. So I'm going to be combining these two values to make up my middle, and my middle's 47. So I knew it wasn't going to be any of these ones, and I get here and I get negative 47. That's equal to my middle. So I can stop once I get my middle. 10k squared minus 12k minus 35k plus 42 equals 0. Let's factor by grouping. We can take out a 2k, which gives me 5k squared minus 6. I can take out a negative 7, which gives me, sorry, that doesn't, 5k squared, 5k minus 6 equals 0. We have a 5k minus 6, and we have a 2k minus 7 equals 0. So 5k minus 6 equals 0, 2k minus 7 equals 0. Add 6, divide by 5, 6/5, add 7, 2k equals 7 divided by 2, 7/2. And my solutions are going to be 6/5, comma 7/2. 6/5, 7/2. Let's check out the solution. 6/5, 7/2. Love it. All right, let's do the next one. So this is not equal to 0. And remember, we always have to equal it to 0. So we'll subtract 6. We'll get x squared plus 10x plus 25 equals 0. I already see that this is a binomial square. I know that this is x plus 5 because binomial square has 4 things. It's 3 terms, second sign positive, first and third are perfect squares, and the middle equals 2 times square root of the first times the square root of the third. So if I take the square root of the first, square root of the third, multiply it and double, does it equal my middle? Yes, it does. So I knew that this was a binomial square. And I'm going to write it like this opposed to writing it like this, because I'm not doing the square root technique. I'm setting each one equal to 0. Subtract 5. X equals negative 5. So again, my solution is one number. In this one, remember with our parabola, so what would the solution look like here? It would look like this, where this value is 6/5 and this value is 7/2. And my A is positive, so that's why I knew it was going up. So those were what those values mean. So number 5, the last one of factoring, we're going to set it equal to 0. Minus 30. And now we look, there's a common factor amongst those three terms. So we need to factor out a common factor. So 6 goes into each of those. So let's rewrite this. And I can do A times C. If you're good, you also should be able to see that, hey, mental math. I don't know if anybody sees that this is going to be n plus 5, n minus 1. Some of you will get good and be able to do that. If you use A times C, that's fine. It's 1 and negative 5. Factors of 5 are 1 and 5. The signs are different, and the bigger is positive. Does that equal my middle? Yes. We'll move this down because we'll still do the technique. So that's n squared minus n plus 5n minus 5 equals 0. Let's factor by grouping. Take out a 5. And then we have, then it brings us to that. Well, technically, we could write it as n minus 1. They have the n minus 1 in common, and then you're left with n plus 5. And now we set each one equal to 0. 6 doesn't equal 0, so that gets negated. We're going to add 1. We're going to subtract 5. And my solutions are negative 5, 1. Again, A is positive, so if we looked at that parabola, we know 1, 2, 3, 4, 5. We know there's a point there and a point there, and they would be symmetrical distance away. So that's one of the other nice things, is we sort of get information about that parabola by finding the zeros. That's what it's called, finding the zeros. All right. Now we move on to the next technique, which is square roots. Well, notice that square roots, we're only going to have one variable. Whenever you have one variable, you're going to use, and it's being squared, you're going to use the square root technique. That's going to be the easiest way. So when we have the square root technique, we're going to isolate our variable. And then we're going to isolate it. We get x squared equals 49/4. We're not going to turn that into a decimal. We're going to keep it as a fraction because we're going to take the square root of both sides. Whenever we take the square root of a variable being squared, we have to introduce the plus or minus of that value. Reason being is whenever we square a negative value, it's going to give us the same as squaring a positive value. So square root of x squared equals x. We're going to get plus or minus square root of 49 over the square root of 4. We'll separate those. You get plus or minus square root of 49 is 7. Square root of 4 is 2. So my solution is plus or minus 7/2. And that parabola has an axis of symmetry right on the y-axis because it's going to be positive 7/2 and negative 7/2. So, and x is positive, so it would look something like that. You don't have to know that parabola stuff. I'm just explaining and keeping it relevant, shall we say, and understanding of where we're going to go with this. In this situation, I want my variable We'll do this. We'll subtract 10. We get negative 3n squared equals negative 147. Let's divide by negative 3. We get n squared equals, now does 3 go into 147? 1 plus 4 is 5, plus 7 is 12. So yes, we know since 3 goes into 12, 3 goes into 147. So let's do that. 147 divided by 3 gives me positive 49. Negative divided by a negative is a positive. Now we're going to take the square root of both sides. N equals plus or minus 7. And those are my solutions. We have a single variable being squared, so of course, logically, we're going to use the square root. We're going to add 3. 2x squared equals negative 17 divided by 2. X squared equals negative 17 over 2. We're going to take the square root of both sides. Square root of x squared equals x, and we get no solution. Why do we get no solution? Because you can't take the square root of a negative number. So at this juncture of your math career, yes, Mr. Mack, doesn't the square root of negative 1 equal I? Yep, we could get an irrational, an imaginary answer. So this would give us 2 imaginary answers. Later on in math, you'll definitely, that will be your answer opposed to giving no solution. But at this point in your math career in 8th grade, the answer is no solution because we can't take the square root of a negative number. But in the future, you're going to get 2 answers because it's plus or minus, and you'll get 2 imaginary answers because it will have the square root of negative 1, which equals I. I stands for imaginary. Didn't know that you were going to get all this background for Algebra 2, which you'll be, hopefully many of you will be doing your sophomore year. Still isolating, we have a single variable that's being squared, so it's easiest to just isolate it. 10a squared equals 280. Divide by 10, we get a squared equals 28. We're going to take the square root of both sides. We get a equals plus or minus rad 28. You can't leave it like that. You're going to have to simplify it. Make sure you always simplify radicals. We see that there's a perfect square in 28. So we're going to get plus or minus 2 rad 7 would be my answer. Whenever you have radicals, always look for factors that have a perfect square as one of their factors. Number 10, solving each equation by completing the square. So now we could have used A times C if there weren't contingencies, but it says that we have to use this method. So we will use this method. Completing the square, we have to move the C value, the constant, over, and we want to isolate the A and B values. And the reason being is we want to create a binomial square. We want to create something, 2 terms, binomial, that are squared, because then we're going to take the square root. So what does this value have to be in order to become a binomial square? Well, the easiest way to do it is you divide your b by 2, which gives you negative 6, and then you square it. So if that value was 36, this would now be a binomial square. It would be n minus 6 quantity squared. So I like that. But since I placed 36 on the left side that wasn't there before, I have to balance the equation. I can't just add 36 to the left side. I have to do it to both sides. So after I factor this to n minus 6 quantity squared, I have to combine these 2 values, and that'll give me 64. Now I like this because I can take the square root of something being squared, and the square root of, if I square root the left side, I have to square root the right side. That will give me n minus 6 equals plus or minus 8. And now I'm going to isolate my variable. And since I added 6 to both sides, and now I have two statements. I have 6 plus 8, and I have 6 minus 8. 6 plus 8 gives me 14. 6 minus 8 is negative 2. So here are the two x-intercepts, or what we call the zeros. Since they are rational numbers, we absolutely could have done a times c. If you get a rational answer, you most likely can do a times c. We can always use the quadratic equation. Always know that you can use quadratic equation for every single problem. But you can't always complete the square, and you can't always use the zero property, and you can't always, meaning the a times c, you can't always isolate for n. So know that there are going to be situations that are better. All right, number 11, we're still completing the square, so we have to move that c value over and isolate the a and b. And remember, a has to be equal to 1. So since a is 1, we can just move the c value over, and now we're going to complete the square. So we'll divide by 2, and we'll square it to get positive 4. What we do to one side, we have to do to the other. That's going to produce this. This value will always be half of b, and that sign will always be there. Okay, so this value here is always half of my b value, and that equals 5. We're going to take the square root. We get r minus 2 equals plus or minus rad 5. Let's isolate r by adding 2 to both sides. And that's my answer. I can't move that. I can't simplify that any further. It's a horrible 5. Come on. Good. Completing the square. So here we have a problem. A is not 1. So the first thing that I might want to do is divide everything by 3. We get r squared minus 4r minus, what's that, 17? 51 divided by 3, 17. Minus 17 equals 0. We're going to add the constant over. We take our a and b values. We're going to complete the square. Half of that squared, half of my b value squared is 4. We get r minus 2 quantity squared equals 21. Square root. Square root. We get r minus 2 equals plus or minus square root of 21. 21. 9 does not go into it. 4 doesn't. 16, 25. So that is simplified. So we will add 2 to both sides. R equals 2 plus or minus rad 21. And that's going to be my answer. Let's go back and make sure. Just what number is that? That is number 12. Just to be checking 2 plus. Good. Excellent. All right. Now we get a fun one. So a is not 1, so let's initially divide by 6. Everything by 6. Did I do that? I hope I did. I didn't. I had to divide that by 3 also. So we got to divide everything. Don't just do the left side. What you do to the left side, you have to do the right side. Just dividing by 0 doesn't give me any value. It still leaves me with 0. Minus 3v plus 4 equals 0. Let's move the constant over. Let's take half and square, which gives me 9/4. So I just draw this in there just for visual purposes, but that b value is still. And let's add it to the other side. We know that this is going to equal half of my b value, quantity squared. That is -16/4 if I change -4 into fourths. Got to know your fractional work. And that's going to be v minus 3/2 quantity squared equals 9, and -16 makes -7. Is that right? I don't know why. 16 minus 9, 7. Ooh, that's going to be interesting. Oh yeah, baby. Let's take the square root. Let's take the square root. Uh-oh. Yeah, hopefully you see. Did I do something? Yeah. Oh, I knew it wasn't right. Where did I make my mistake? I knew it wasn't going to be right. I knew I was like, wow, we have a negative value again. That equals 2, Mr. Mac. I hate making mistakes in a video. But it just shows that even the teacher can make mistakes. So that's -2. That's going to be -8/4. This gives us 1/4. This gives us 1/4. And notice when I caught my mistake, when I saw that it was going to be no solution, I kind of knew that those are unique. So we have to be very careful. You saw at what point my brain says, hey, slow down. And we should always be checking our work because we're not going to be perfect. So when you're doing your work, always be open for those intuitions, those feelings of, I don't feel like this is right. This is giving me a weird answer. When you get a weird answer, you should definitely make sure that you go back and check your work. So lesson learned here. So the square root of this is going to give us v minus 3/2 equals plus or minus square root of 1 over square root of 4. V minus 3/2 equals plus or minus 1/2. Let's add 3/2 to both sides. We're isolating the variable. We get v equals 3/2 plus or minus 1/2. Let's do 3/2 plus 1/2 and 3/2 minus 1/2. We get 4 over 2, which is 2. We get 2 over 2, which is 1. So my solutions are 1, 2. Woo! Good catch, Mr. Mac. Sorry about that. All right, now we move on to quadratic formula. Quadratic formula, a, b, and c can be anything. It just needs to be set equal to 0. So we're not concerned about what a is, what b is, or what c is. We just got to make sure that it's equal to 0. So my a value is equal to 2, my b value is equal to 3, and my c value is equal to -9. So using the formula, in this case it's going to be b equals, it's whatever that variable is. B is going to equal the opposite, let's use x just because we're going to show the formula, opposite of b plus or minus square root of b squared minus 4ac all over 2a. So the opposite of b plus or minus square root of b squared minus 4 times a times c all over 2 times a. So that gives us -3 plus or minus 9 plus 36 over 4. -3 plus or minus 36 plus 9 gives us 45. Is it really this ugly? So at this point, I'm thinking, is it really going to be irrational? Is the first problem that I do irrational? We'll see. We'll continue and then we'll go back and check our work. Plus or minus, we're going to break that into rad 9, rad 5. And then this becomes negative 3 plus or minus 3 rad 5 over 4. So that's what I got. I'm concerned about that answer. So I'm going to go back and check my work again. 2 mistakes and 2 problems? I hope not. We'll see. A is 2, B is 3, C is negative 9. That's good. Opposite of B, plus or minus B squared minus 4. Found it. 4 times 9 is 36. I forgot to multiply by 2. 36 times 2 is 72. 72 plus 9 is 81. Mr. Mac, back-to-back mistakes. Square root of 81 is a perfect square. So we get 9. And so we are going to split that up. Minus 3 plus 9 over 4 and negative 3 minus 9 over 4. That gives me, 6 over 4 or 3 halves. This gives me negative 12 over 4 or negative 3. So my solutions are negative 3 and 3 halves. A little bit more realistic solutions. Back to back, Mr. Mac. That's not good. Negative 3, 3 halves. Negative 3 and 3 halves for number 14. Sorry. Ooh, I like this one. This one's good. Right? We look, typically, we wouldn't use the quadratic formula here. We would just solve and isolate for x. But it tells us to use the quadratic formula, so this is good to know how. A is 4, B is 0, C is negative 2. Opposite of B, plus or minus square root of B squared minus 4 times A times C. Let's see if Mr. Mac can do it correctly on this one. So that's negative 0 is 0. 0 plus or minus 0 squared is 0. Now, negative 16 times negative 2 is positive 32, Mr. Mac. 4 times 2 is 8. Well, the 0 plus or minus, we'll keep the plus or minus, but we don't need the 0 outside there. Square root of 32 over 8. We cannot. One's inside the house, one's outside the house. But we can simplify this radical. We know that 16 and 2, 16 being a perfect square. And now we can simplify that because the 4 is on the outside and the 8's on the outside. So we're going to get plus or minus rad 2 over 2. Right? 4 goes into 4 once, 4 goes into 8 twice. So this is going to be my answer. So we get plus or minus rad 2 over 2. That one I'm certain and confident in. Schmeck got one right. All right, first thing, let's set it equal to 0. Make sure that your quadratic formula, your equation, your polynomial equation is equal to 0. So let's do A is 2, B is 4, C is negative 16. So we can do opposite of B, plus or minus square root of B squared minus 4 times our A value times our C value, all over 2 times A. Negative 4 plus or minus square root 16, plus. So 8 times 16. 8 times 16 gives me 128. All over 4. We have negative 4 plus or minus 16 plus 128 gives me 144. I like that. Reason I like that is because it's a perfect square. Whoops. Plus or minus square root of 144 is 12, 4. And so we'll split these up. Negative 4 plus 12 over 4. Negative 4 minus 12 over 4. Oh, I didn't mean to do that. Go away. I meant to extend the page. Negative 4 plus 12 gives me 8 over 4, which is equal to 2. Negative 16 over 4, which is negative 4. So my solutions are negative 4, 2. Nice and clean. And the last one, I don't know why I did one more. Oh, I bet you it becomes irrational. You get 2x squared minus 4x minus 2 equals 0. A is 2, B is negative 4, C is negative 2. Opposite of B, plus or minus square root of b squared minus 4 times a times c, all over 2 times a. You get 4 plus or minus 16 plus 16 over 4. 4 plus or minus rad 32 over 4. Rad 32 can be broken into rad 16, rad 2. We've seen that before. 4 plus or minus 4 rad 2 over 4. So we can't simplify this, meaning we can't simplify it to a rational number, but we see that each of these, that, this, and this, all three have to have a common factor in order to reduce that. They do. 4 goes into each of those. So you get 1 plus or minus rad 2 over 1, which just means 1 plus or minus rad 2. That is going to be my answer. Simplifying radicals, especially those types of problems, are going to be somewhat challenging for people. So understand that. Finito. Nice job. Sorry about those 2 mistakes. But it just shows that we're all going to make mistakes every now and then, even the teacher. So come and see me on my Zoom if you have questions. Good luck.